This conference will now be recorded.
We need to connect to a data source. Okay. After we get connected to a data source, we have to tell Tableau exactly which all tables we require to create the reports or create the charts. And then when we reach the worksheet, we were trying to understand about the different sections here, like the menu bar on the top, followed by that we have the toolbar. There is the data pane where we can see the names of the data sources that we are connected to. Fields from the data sources are segregated as dimensions and measures. So there is one very subtle line which divides them. You can see this above the line are dimensions, and below the line actually are measures. Measures in Tableau are always aggregated based on some default aggregation property. Okay, so what would be measures? Measures would be data which when aggregated will give you meaningful result. Okay, and dimensions will be data which we would not want to aggregate. Instead, look at the data as is. Look at the values present in that field, and not all the values, not all recurring values, but unique values. All the unique values. Not audible? It looks fine at my end. Are you all facing the problem? Are you able to hear me?
Yes, ma'am.
You're able to hear me? Okay, so okay, Ibrahim. Okay, and then when we use a dimension or any field on the columns shelf, we are basically telling Tableau that the data in that field is supposed to appear as a column. So it will align itself horizontally, and you can see each member appearing as a column because it's on the columns shelf. Each member appears as a column, means, and it is a blue colored pill. Blue colored pill indicates that the data is discrete. Discrete means it will have distinct values in it, and you cannot basically decimals will not make sense there. And yeah, I think that is about it. And when you take a measure, what happens is we get an axis with a range of values. Measure is continuous, something where decimals will make sense. And when you take something to the rows shelf, you're basically telling that the data is supposed to cut across rows, and that is what is happening here. It formed a y-axis. This is what we had discussed, and we also understand the purpose of show me panel, why we need it, how it helps us. And we also discussed about different methods that are available to save and share our work. Okay, static methods we have seen, wherein you can copy the visualization as an image, or you can export it as an image, export the worksheets in the workbook as a PowerPoint or as a PDF, right? Copy the data behind the view, copy the data in a text table format. Then dynamic ways, or more interactive way of saving the workbook would be to save it as a workbook or a packaged workbook. When you save something as a workbook, all the worksheets created in that workbook will be saved along with the connection details to the resources used to build the worksheets in that workbook, right? And when we save something as a packaged workbook, the local data is packaged along with the workbook. Apart from the contents of the workbook itself, the data is also packaged. Not all the data, not each and every data from all the data sources, but the data that is present on your local machine where Tableau is installed, means something that is a local resource. That resource could be data, that resource could be files, that resource could be shape files, that could be images, that could be geocoding. Anything that you're picking up from your own machine where you have Tableau installed becomes a local resource. Okay, and then we know that we can publish it to Tableau server or Tableau online using this publish option. Or we can also, if it's something very generic that we are creating, nothing very secure, something that we would like to share with the entire world, showcase the talent, then you can save it to Tableau Public. However, when you're saving something to Tableau Public, what is the prerequisite that we have to follow? On Tableau Public, we cannot save a workbook which has live connection to the data. It is supposed to be an extract, which means you have to first of all extract the data and then save the workbook on the Tableau Public server, which means only packaged workbooks can be saved. The moment you say you are extracting and you want the extract to be packaged in the workbook, it is supposed to be internally packaged inside the workbook. So it is a packaged workbook that we save on Tableau public at all the time. These are the options that we had discussed, and all this was basically so that we may go ahead and look at Tableau architecture and understand Tableau architecture. So we are going to begin our discussion for today with Tableau architecture itself. So this diagram, when you look at it, it always reminds me of the definition of a computer. You know, back in school when computers were just being introduced as a subject, first thing we were made to learn for almost 2 months is the definition of a computer. Computer is an electronic device that takes the input, processes the data, and gives the output. Takes the input, processes whatever input it has taken, and gives us the output. So pretty much the same paradigm. Actually, if you remember that definition, I think this architecture perfectly fits into that definition. So what does Tableau Desktop do? It will get connected to data coming from multiple data sources. It has immense capability when it comes to data connectivity. It can connect to a wide variety of data sources using either live connection, which is a direct connection to the data, or extract, where we fetch the data, save a copy of it on our local machine, and access it from there, and periodically from time to time make sure to refresh it so that we get the latest information. So that these are two modes in which we can access the data from the input data sources. After we get connected to the data, what is the next obvious thing? We will create the charts. We will create the workbooks. We will create the reports. We'll create the dashboards, right? After creating what is to be created, the next thing is we have to look at how do we send it across to the end users, means the output part. So what can we do? We can send it as a PowerPoint presentation, as a PDF. You can take an image and paste it in a Word document and send it. You can copy the data in the tabular format and send it. So what will the end users be able to do with this kind of information? They will not be able to interact with the reports. They will not be able to modify the reports. They will not be able to add anything new to the reports. At most, they will be able to see and give an opinion, right? Understand what is going on with the business. So static readers, that's why we call them static readers, who will not have any interactive capabilities. Other thing is we can save it as a workbook or a packaged workbook. Now let's say I saved it as a packaged workbook. Let us say I have saved the workbook which I created on Tableau Desktop as a packaged workbook, and I send it to you in an email. I send it to you in an email. And let us assume you do not have Tableau Desktop. You do not have Tableau Desktop. Then how will you open that book and interact with it? So if you're sharing your workbook with somebody who may not have Tableau Desktop, you can ask that person to download Tableau Reader. Tableau Reader is a read-only software, which is again free software that is given by Tableau, a free tool. So if somebody installs Tableau Reader, they will be able to open packaged workbooks. Now, this is also a certification and interview question. What type of workbooks can be opened on Tableau Reader? Why do you need Tableau Reader in the first place? You need Tableau Reader to be able to open packaged workbooks created on Tableau Desktop. All right. So what type of workbooks can be created on Tableau, can be opened on Tableau Reader? Only packaged workbooks, not normal workbooks, only packaged workbooks. Why? Because the data is expected to be internally packaged in the workbook. Only then we can open it on Tableau Reader, which in turn means what? If your data is coming from files, if the data that you have used to create the workbook is coming from files, then they get packaged internally in the workbook. So you will be able to open them on Tableau Reader, the packaged workbook with the data that is packaged internally. But if your data is coming from any databases where the data is not going to be packaged, you cannot open it on Tableau Reader. So a lot of limitations there, right? Lot of limitations. However, if you have created some workbook using data coming from different files, and if you have saved it as a packaged workbook, you can definitely open it on Tableau Reader and interact with it. If you don't have Tableau Desktop, you can do this. Now, what will a Tableau Reader look like? Let me show you. It is a read-only tool, as the name itself suggests. So we will not be able to interact with it. We will not be able to modify anything. We will not be able to create anything new there. However, it is interactive. Unlike static, where people cannot even interact with the report, when they open it on Tableau Reader, one small advantage is that people can interact with it. End users can interact with the report, meaning if there are any parameters or there are any interactive filters, some sort of interactivity that you have provided in your workbook, they will be able to use that feature. We will be learning a lot about how to make the workbooks interactive a little later in our course, but here I'll just give you a small demonstration. Now what you're looking at on my screen is called as a panel chart. Okay. Now it has multiple grids, multiple columns, information about different states and sales there. I'm looking at 5 columns. Suppose I bring it down to 3, then the number of columns in my panel chart will reduce to 3. Okay, suppose I increase it to the highest, let's say 10, then the number of columns have increased to 10. We will not be able to do such things if it is an Excel, if it's a PowerPoint or a PDF, right? Or an image. However, the advantage of Tableau Reader is it is not absolutely static. It is interactive in the sense we will be able to modify the filters and parameters and the chart will get updated accordingly. However, you will see that there is no data pane, there's no columns and rows shelf. There's nothing that will help you to modify this chart or create anything new in this workbook. Okay, so that is the purpose of Tableau Reader. Now you might be getting a question in your mind. If you have created a packaged workbook on Tableau desktop and sent it to a person who does not have Tableau desktop, why can't that person install Tableau Reader, which is not Reader, sorry, Tableau Public, which is a free tool, and use it to open the workbook? Getting my point? See, Tableau Public is a free software that is available. Anybody can download and install Tableau Public also, and they can create reports over there. They can, save their work on Tableau Public server. So if a workbook is created on Tableau desktop, why not ask the end user to whom you are emailing this workbook to open it on Tableau Public? Why do you have to ask them to install Tableau Reader and only then open the packaged workbook? That is because, yes, limitation with Tableau Public. That is a limitation. Workbooks created on Tableau desktop cannot be opened on Tableau Public. Very important point to note. Workbooks that you create on Tableau desktop cannot be opened on Tableau Public. They cannot be opened on Tableau Public tool. Not possible. Only workbooks which are downloaded from the Tableau Public gallery or the Tableau Public server can be opened on Tableau Public. Workbooks created on desktop directly cannot be opened on Tableau Public. Okay, that is why we use Reader instead. So one way of sharing is with static readers. Other way of sharing is in a slightly more interactive way is you can save the workbook as a packaged workbook and ask the end users to install Tableau Reader and interact with the workbook. Or if they have Tableau desktop, then nothing like that. They can directly open the workbook. No worries about it. But how do you share your workbook in a very secure manner with a very, very large group of audience? How do you share your workbook in a fully secure manner with a very large group of audience? By publishing it to Tableau server, we can do that. By publishing it to Tableau server. So when you decide to publish something to Tableau server, the first layer that you encounter is security. Depending on the user ID, which could be an email ID or some user ID created for you or some, however your organization sets it up. So depending on the login ID that the person is going to use to log into Tableau server and access the report, you can give them permissions. Let's say user 1, I will give only view access. User 2, I will give them explorer access, which means they will be able to edit. User 3, I will give them creator access. Creator means a person who can even create new workbooks there. Or I will just make that person an administrator on the server, right? So when you publish, you can decide what kind of permissions you want to give to the users on your workbook. Very secure. And on top of that, of course, when you publish, of course, they go and get saved on Tableau server. There's a huge space allocated to store all the workbooks on Tableau server. Okay. And next thing is management and automation. Let us say we are dealing with an extract connection, then that needs to be periodically refreshed, right? After we publish it to Tableau server, the job, our role will end there. We will publish it there and we'll leave it there. But who is going to refresh it from time to time? You can set up a job that will schedule the refresh. You can schedule a refresh job which will automatically refresh the extracts, thereby refresh the reports at regular intervals of time. Okay. And from within Tableau server also, it is possible to make a direct connection, live connection with any data source of your choice and create reports there itself, or extract the data from the database, save the Tableau data extract, and using that create the reports. So Tableau server is not just a repository which you use to share your work with a large group of audience or collaborate your work across, the organization from different people who are working on it, but it is also a place where we can create the workbooks, okay, and edit the workbooks. Scheduling is possible via server. Yeah, scheduling is possible via server. Correct. Okay. Then comes the point where, let us say I have uploaded something to Tableau server and I have, given access to different people. I have scheduled the refreshes, everything is done. So how will the end users be able to access that report? They can log into Tableau server with their own user ID, either from an internet browser or from their Tableau mobile app, or they can access it, they can download the workbook and work on it on their own Tableau desktop tool. So somebody could access the workbook on their internet browser. They may be looking at that workbook which you uploaded there on their internet browser. Somebody could be looking at their at that workbook on their mobile app, or somebody just wants to download it and work on their own version of Tableau desktop tool. So it doesn't matter. Depending on the type of permissions these people have, they can access the workbook from different sources. So let us call all these people as our clients. Okay, client will access the report and they will look at it and interact with it. So different clients with different permissions accessing the reports from different devices, right? Then who is going to monitor? Somebody should stand there and monitor, right? In the server, somebody should be there inside that server machine telling, okay, this request has come from an internet browser. It could be any browser, okay, not just Internet Explorer. It could be anything, Mozilla, Firefox, Google Chrome, anything. Somebody is trying to access the report from the internet browser. So let me create something compatible with the browser and give it to him. Somebody is trying to access it from the mobile. Let me take that, compatible mobile compatible version of that report and give it to that person. Somebody wants to download it. Let me just allow that person to download, depending on the permission, of course. So who is going to stand there inside the server and monitor such things coming from the clients is the presentation layer. So presentation layer is that component in Tableau server, which is basically looking at the permissions that people have on the reports and the devices from which they are accessing the reports, and accordingly it is going to respond to the request coming from the clients, from the end users. Is it clear? Tableau architecture. Take a moment to process this information and let me know if you have any questions here. So next we are going to discuss about Tableau server architecture. We have seen Tableau architecture. Now we're going to proceed to Tableau server architecture. Now we said that even in Tableau desktop, actually, some of these components are there even on Tableau desktop. Now let's say when we get connected to a data source and we decide to create an extract, right? Suppose who is creating the extract for us? We said Tableau scans through the initial few records in the data and decides on what should be the data type of that field. Now, who is deciding what should be the data type of the field, right? And Tableau is also segregating the data into dimensions and measures. Now, who is doing this activity of segregating the fields coming from the database into dimensions and measures? We also said that Tableau also distinguishes between geographic and non-geographic data. How and all we did not discuss. We'll discuss when we get to that point. But how does it actually deal with data, right? How is it actually dealing with all of this data and doing all these activities, creating the extract and deciding what should be the data type of the field, deciding whether a field is supposed to be a dimension or a measure, and deciding what should be the default aggregation property of the measure. What should be the default aggregation property of the measure, right? Yeah, discrete and continuous, discrete and continuous. So blue colored and green colored, right? Why should I give blue color to a pill? Why should I give green color to a pill? Which color should be blue, thereby indicating discrete? Which pill should be green, thereby continuous? So all this is happening depending on the data, right? There is a patented software which Tableau people use called as Tableau's Fast Data Engine, which will look after all these things. Tableau's Fast Data Engine will look after all these things. It will do all these activities. So whatever data related things are happening, it is being done by a patented technology which Tableau people use called as Tableau's Fast Data Engine. Okay, it is a main component. Now, we are looking at Tableau server architecture. Client data these days can be, it could come from anywhere. It could come from a wide variety of data sources, multiple data sources from anywhere. We cannot tell that, okay, if your data is present in so and so data source, only then I will work on it. Otherwise, I will not work on it. We don't have such kind of liberty, right? Client data could be coming from anywhere. Now, no matter where the customer data is coming from, Tableau can handle the data because it has a data server component. One of the main server components, one of the main components in Tableau server is data server, which will be able to handle all data related things. Data could be coming from a data warehouse, data mart, which is a subset of a data warehouse, files on your machine, or cubes, multi-dimensional databases. No matter where your data is coming from, Tableau's data server component will handle it. Okay. Fast data engine will create the extracts and do all the activities that we discussed. Now, suppose your data is coming from a relational database. Suppose your data is coming from a relational database. Then we can also write SQL statements, which we will be looking at in module 5. Okay. We can write SQL statements and fetch only the data that we need for our analysis. So SQL connector is there, which will handle SQL statements. If you're communicating with data coming from cubes, multi-dimensional data sources, then you'll have to write MDX, that is multi-dimensional expressions, statements, which are called as MDX statements, which are interpreted by the MDX connector. And many data sources are uploaded to Tableau server itself directly. Sometimes, the client says, I'll put the data on server, take it from the server and create the reports. So data could also be directly present on Tableau server itself, from where we may have to access it. So all data related things, data server will look at. Application server, who is application server? It is that guy, that person present in Tableau server, that component, which is the presentation layer. In the previous slide, I spoke about presentation layer, right? Same thing. That presentation layer is nothing but application server, which is going to look at the requests coming from the clients. Who is the client? What is the kind of permissions that person has on the server, on that report? And how, from where is that person trying to access the report? It's going to check all that and respond accordingly to the client. So this is like the person who's facing the client and handling the client requests. SQL server is another main component. No, SQL server, MDX connector, repository, they don't pass through fast data engine. Okay, now, yeah, it works in combination though. So when you want to create an extract, let's say you have written a SQL statement and you have fetched the data for your analysis, but that data you want to extract, then again you need help from fast data engine. It works, they work together. Let's say you have written an MDX expression and you have fetched the data for your analysis, which you want to further extract, then again you need help from here. Repository could be a Tableau data extract also. In that repository, data repository, you can have normal data sources like Excel files, Access files, okay, PDF files, JSON files, but you can also have Tableau data extract files there. So they all kind of work together as a part of the data server. They work together wherever necessary. Wherever it is not necessary, they act independently. Okay. But ultimately, no matter from where you're connecting to the data using SQL statements or just direct connection or MDX or TDE, whatever it is, or a hyper, somebody has to segregate the data into dimensions and measures. Somebody has to segregate and understand continuous and discrete. Somebody has to tell what is the default aggregation property. Somebody has to distinguish between geographic and non-geographic, right? So that is all taken care by the fast data engine. Okay. So the data definitely has to go through fast data engine, correct? Whether or not we are creating the extract. Then SQL server, visualization query language. It stands for visualization query language. So SQL server is a component that is going to monitor every activity that we do on Tableau desktop and Tableau server basically, and convert our actions into charts. Every drag and drop, like suppose I drag category and put it on the columns shelf. Who is telling that category is discrete? Fetch the unique members present in that field, make them appear as columns. Profit was taken to the rows shelf. Who told Tableau? Profit is on the rows shelf, so it has to form the y-axis, thereby cutting across columns, and the range of values is fixed. So basically, who is creating the graph for you, depending on how you interact with the tool, is your SQL server. So this is called as the heart of Tableau. SQL server is the heart of Tableau. Okay. It is basically building the charts for us as we work on it. Then there is gateway load balancer, which is not compulsory. It may or may not be there depending on the server environment. Now, usually a small to medium scale organization, they can handle things with just one machine as a server. But if it is a very large scale organization and one machine is not able to handle the load coming from, maybe hundreds of thousands of clients accessing the server with different requests, and the server could get overloaded sometimes. So if at all it is that kind of an environment with huge number of clients accessing the database, accessing the data server, Tableau server, what Tableau people or what the organization can do is they will set up one machine as a primary server, and they will set up multiple other machines as worker servers. Okay, as worker servers. So worker server 1, worker server 2, worker server 3, so on and so forth. Primary server acts as your load balancer. Primary server acts as the gateway load balancer. So when the requests are coming from the client, they are going to first hit the primary server, which will not process the request. Distributing the workload. Perfect, correct. Distributing the workload. So it will not process the request. Remember, primary server will not work on the request. It will just direct the request to different worker servers. Whichever worker server has little lesser load on it, it will route the request there. Worker server again comprises of all of these components except for the load balancer, because that is the primary server, right? So worker server consists everything. It will look at the request, process the request, and reply to the client, send the response back to the client. So you're basically distributing the workload. When there is a lot of load, only then. Otherwise, usually with a single server environment, it works perfectly fine. Now, what do you think will happen if the primary server itself goes down? Because we are telling that all the requests in a multi-server environment, they are sent to the primary server. Primary server will route it to the worker servers. Primary server will route it to the worker servers. What do you think will happen if the primary server itself goes down? If the primary server itself goes down, the Tableau server administrator will step in and they will assign the role of primary server to one of the worker servers. Okay, so one of the worker servers will temporarily assume the role of the primary server. Temporarily assume the role of the primary server. And it will start routing the request to the rest of the servers, worker servers. Once the problem with the primary server is fixed and it is back up again, primary goes back to being the primary, worker goes back to being the worker server. Okay, that is how it is configured by Tableau people. So why this is nothing but risk mitigation. If at all we run into that risk of losing the primary server, the show should not stop, right? The work should not stop. So one of the worker servers will be made the primary server for the time being. Later on, it will go back to being the worker server and primary goes back to being the primary server. So it's like this. Suppose there is a board of meeting. Okay, there is a meeting happening in some location and the board of directors of an organization. Okay, let us say the board of directors of an organization, all of them are supposed to start from location 1 and they are supposed to reach location 2. Let's say they're all supposed to start from Hyderabad and they are supposed to reach Bangalore. All of them have to start from the same, go from the same airport. All of them are supposed to reach the same meeting destination. But they will all never travel in the same flight. They will never take the same flight. Why so? Perfect. Risk mitigation again, right? If God forbid something happens and the plane crashes or whatever, then we are at the risk of losing the entire board members. And when the board members are gone, there will be utter chaos. There is even the risk of having to shut down the organization, right? So risk mitigation. So they make sure that they don't travel together. Somebody should be there even if something worst happens. So they're preparing themselves for the worst. Risk mitigation. They're planning ahead for such things also. Even it's very unlikely, they plan for such things. So that is risk mitigation. Same thing here. If the primary goes down, it does not mean everything will come to a standstill and stop, right? So that is about Tableau server architecture. Now you can go through the presentation for whatever we have discussed. You will find it here. Last topic for module 2 is to discuss about the limitations of Tableau public. Okay, limitations of Tableau public. I will show you Tableau public now and let us look at the limitations. So you see Tableau Desktop Public Edition. So this is Tableau Desktop Public Edition, which I'm opening. We'll just spend about 5 minutes understanding this, and then we can proceed further. So you see the Tableau public interface looks very much like your Tableau desktop interface. Okay, we have the connect section here, we have the open section here, and we have the discover section here. And even here, the first limitation you will notice is with respect to the data connectivity. Okay, with respect to data connectivity, we have very limited data connectivity options. Clearly, it's glaring at us, right? It's just glaring at us. So it's telling, okay, I give you only this much, only this much. That is the first limitation, limited data connectivity. Second limitation, then how do you connect to a data source is the same. Select the type of the data source, navigate to the place where you might have the data source saved on your machine. Okay, hit open. That will take you to the data source page. And once you are on the data source page, you can see the name of the data source, list of worksheets present in it. Drag and drop the worksheet here. Data will appear. Preview of the data comes up on the data grid. We can go to metadata. We can sort the data. We can edit the name of the field using rename. We can give the values in the field an alternate name by using aliases. We can hide the fields which are not necessary. So all these are the same. But the difference that you will find here, the second difference is there is no live or extract option. On the top, there is no live or extract connectivity options because from Tableau Public, we can never make a live connection to any data source. By default, it is an extract, which means the moment you connect to the data source, Tableau will automatically extract the data and it will save the extract internally as a part of that workbook itself. And you can see once you reach the canvas by clicking on sheet option, worksheet option, we are connected to Tableau data extract. You see the barrel icon there, 2 barrels with an arrow mark connecting them, which indicates that it is a Tableau data extract. That is the second thing, no live connection option. Third thing is, again, with respect to creating the charts, it is perfectly fine. With respect to creating the charts, you can use this perfectly fine. There are no limitations with respect to creating the charts. Whatever you create on Tableau desktop, all the charts can be created here. However, the next limitation is with respect to static methods of sharing your work. You see, copy and export features are disabled. Copy and export features are disabled, deactive. And when you right click on the context menu, you will not even find the option of copy. Okay. Next thing is when you go to file menu, exporting it as a PowerPoint or using the print to PDF option are not available. So we do not have any static methods of saving or sharing our work. Okay, that is the next limitation. Then if you decide to save it as a workbook, as a packaged workbook, it is supposed to be a packaged workbook only, right? Because data is internally packaged, the extract is packaged. So when you decide to save your workbook, you will not be able to save it locally on your machine. You might have noticed save or save as options are not available. It is save to Tableau Public or save to Tableau Public as with a different name. Okay. So you can only save your work that you create on Tableau desktop on Tableau Public server or on the Tableau Public gallery, nowhere else. Which means what? When you create something on Tableau Public, if you want to save it, you have to put it on the gallery. If you put it on the gallery, you're opening it to the entire world. Anybody can access it. So there is no security involved. That is why Tableau Public is not used in a corporate environment, even though it is for free, because there is no way of saving and sharing your work in a secure manner. Okay, that is the major limitation actually. No local save option. You cannot save your work locally. Next thing is, on Tableau desktop, there is one feature called as geocoding. What is it and all we will discuss in detail when we get there. There's a feature called as geocoding, okay, which you will not find on Tableau Public. Okay, and from Tableau desktop, we can get connected to analytics extension. We can manage analytics extension connection, which means we can get connected to R and Python. But on Tableau public, we do not have the option for getting connected to an external service like R or Python. Okay, so these are the limitations. Some of them I have shown you, some of them I will be showing you in the next few classes. So limited data source connectivity is one thing. Cannot save your work locally, it can be saved only to Tableau public gallery is the next thing. No live connection option, all connections are by default extracts. No option to export the visualizations as images or copy the data as a crosstab. No option to print to PDF, no option for export as a PowerPoint, no custom geocoding, cannot integrate with R or Python. These are the limitations of Tableau public over Tableau desktop. However, even with all these limitations, it is an amazing tool which will help you continue your learning journey on Tableau desktop after you have used up the trial. Okay, if you don't have the license, if you already have the license or you have student license, it doesn't matter. You can continue using it, but otherwise, okay. With respect to learning and mastering the tool, with respect to creating the charts, with respect to creating the reports, there is absolutely nothing to be worried about. You can use Tableau desktop, Tableau public perfectly fine for such activities. So what I would personally recommend is those of you who are using Tableau public, those of you who are using the trial version of Tableau desktop for 14 days. Okay, those of you who are using the trial version of Tableau desktop for 14 days, what you do is as in how you keep creating the reports, the workbooks for every module, make sure to save them on Tableau public. Create an account for yourself and make sure that you save your work, a copy of your work on Tableau public also. When you save it on Tableau public, the advantage is even if you use up the trial and you're not able to use Tableau desktop, you start using Tableau public after a couple of months. Because you would have saved your work on Tableau public, you can download it from Tableau public, those workbooks, and you can open them on Tableau public and continue working on them or refer back to them. Got my point? Workbooks that you are creating on Tableau desktop cannot be opened on Tableau public. So how will you refer back to them if you have any query? You save a copy of these workbooks which you are creating during the training for every module, save it on Tableau public. So when you save something to Tableau public, what happens is you can go to your Tableau public profile and download that workbook. If the workbook is downloaded from the Tableau public gallery, it can be opened on Tableau public tool. Is it clear? Why I'm asking you to save a copy of all the work that you do during the training on Tableau public? Because at a later point of time, if you have to refer back or work on it, you can download it from your profile in Tableau public and open it here on Tableau public tool and edit things. Okay, hope that is making sense. No, Tableau public is not limited by time period. You can use it forever. You can use it forever for free. All right. Now, proceeding to module 3, where we will be looking at some basic charts in Tableau, where we begin with text tables and highlight tables, generated fields, bar graphs, circle views, bubble charts, pie charts. This is something we have done, differentiating discrete and continuous data, and we look at line and area charts. This is the agenda for module 3. Now, do you all have sample superstore and have you all installed Tableau, either public or desktop, whatever you're working on? Anybody who does not have sample superstore yet? If you have, then all of you please open Tableau, whatever you're using, Tableau, whichever version, open it. Get connected to the orders worksheet present in sample superstore. You have seen the steps, so I'm sure you'll be able to do it right. Please get connected to the orders worksheet present in sample superstore Excel workbook, Excel data source. Done. Okay. So how will you do it? On the start page, you will select Microsoft Excel. Okay, anybody who needs any help here, please look at my screen and replicate the steps. You will get connected to, you will choose the file type as Microsoft Excel. Navigate to the place on your system wherever you have saved Superstore, select it and hit open. When you do that, you should all be on the data pane, on the data source page. Just double click on orders or drag and drop it here. Both will work. Either double click or drag and drop it there. You should be able to see orders. And all of you should be able to see a preview of your data on the data grid. Otherwise, when you reach the canvas, you will get an error. Okay. Then you proceed to the worksheet. Okay. So let us go ahead and build our first chart, which is a text table. So when should we go for a text table? Given so many different ways to visually represent the data, right? Given so many ways to visually represent the data, when do you think we should still go for a text table? Basically, I would say whenever you have an eye for detail, when attention to detail is important, when the actual values are more important towards the decision making rather than a simple comparison. Where do you think you will find text tables a lot? Mostly financial reports of any organization. They do have profit and loss statements and balance sheets, right? Revenue reports, sales reports, marketing department, the kind of leads that they get on a daily basis. So wherever you have actual data that is going to play a significant role, we have to go with text tables, especially financial reports, sales, revenue, profit and loss, all these things. So that is when to create a text table. When should we create a text table? When you have an eye for detail. How to create a text table, we will see. It again is a generic chart. It's your choice how you create it. There is no rule as such to decide the structure of the table, your choice. Let us say my requirement is to look at the profits of different subcategories, and I want to do that by creating a text table. I would like to represent the profits across different subcategories by creating a text table. Okay, so it's my choice. I will take subcategory to the columns shelf. So when I take subcategory to the columns shelf, what will happen? The members in that field will appear as columns. Accessories is a column, appliances is a column, art is a column, binders is a column, so on and so forth. However, I'm kind of not liking this chart because I have a scroll bar. There are a lot of subcategories which are not fitting on the screen. Names of the subcategories are getting truncated because Tableau cannot accommodate the full name in that given space. Not looking so good. Let me try by putting it on the rows shelf. Definitely an improvement of what we had earlier. This structure looks much better. So it's your choice. It's your call. I have taken it to the rows shelf. I can see the names of the subcategories listed out as rows. So it is vertically aligned. Now I'm interested in looking at profit information here as what? ABC, you see here, ABC, ABC means Tableau is also expecting that we will create a text table. We will put some data here. Okay, Tableau is also expecting that we are probably trying to create a text table and we will put some data here. That is why it is giving ABC. So I will take profit and put it in the text shelf present on the marks card. text shelf, when you drop it on the text shelf in the marks card, the sum of profit per subcategory is appearing as text. Why as text? Because we took it to the text shelf. Okay, why as text is because we have taken it to the text shelf. As simple as that. So it's in Tableau, it's all about connecting the dots. Okay, it's just like you connect the correct things, that's all. So I took profit to the text shelf, I got information in text format. Now let us change the requirement. In addition to profit, I want to show sales also. In addition to profit, I would like to show the sales. Then what to do? Two methods of doing it again. I will take sales and drop it inside the text shelf itself, like earlier. Okay, I have decided to take profit and put it inside the text shelf itself. When I do that, what happens is I will get a cell with profit and sales in it. So in one single cell, we are looking at the profit value. Below that, the sales value. In a single cell, we are looking at profit followed by sales. Why? Because we have profit followed by profit, we have sales in the marks card. Suppose you rearrange, suppose you bring profit down below sales, same thing will happen here. Look at the data now. I have sales on the top, below that I have profit. Okay, so it depends on the sequence in which we place the things on the marks card. Now, let us say this is not looking good. I'm not very happy with this, where I'm putting two values in a single cell. This is called as a cell. So I'm not happy with it. So I will do one thing. I'll remove sales from here. Let profit be there. I want sales to appear as another column here. Like profit is a column. I want sales to show up as another column here. Then what to do? Okay, please observe very carefully. We will take sales. We will take sales, take it, and place it inside the text table where you see the values. You see how a black outline came around the profit values, and you see how the watermark show me is there on the mouse pointer. That is when you will leave sales on the graph. When you do that, sales appears as another column. Please, all of you do this and make sure you have profit as one column and sales as another column. Anybody who's not able to do it, let me know. Okay. Right. Now, how many of you are attending only Tableau, have enrolled only for Tableau? Okay, all right. So profit is a column, sales is a column, and I hope all of you are able to. Okay, thank you for the reply. You're not getting, oh, okay. So Jagannath, if I make you the presenter, will you be able to share your screen? Or do you want me to just do it one more time here? Did you get sale profit? Are you able to do it till here? Do you see profit? Different format. Okay, let me make you the presenter then. I have given you presenter access. You will see the icon to share your screen. Click on screen share icon and you'll be able to share. All right. This is fine, no? You're seeing the names, but where is the text information? I'm not able to hear you. Can you remove profit and sales, which is there in the marks card? Let us put it again. Remove profit, remove sales.
Is it okay now? Is my voice okay now?
Now I'm able to hear you. Yeah, take
Okay.
profit to the text shelf. Where is it appearing? It's not appearing, no?
Yes.
Okay, do one thing. Can you open a new worksheet? Just click
Yeah,
on new
sure.
worksheet. Click on subcategory. Hold
Okay.
down the control key. Hold down the control key and select profit.
Oh, sorry.
Okay, now
Okay.
go to the show me panel. Go to the show me panel. Open that and choose text table, the first one there. Yeah, something is wrong here. It's not creating text table properly for you.
Yes. So this got categorized with the customer order, location, and product. I think this shouldn't
That should be
happen, right?
fine.
Yeah.
It
Okay.
doesn't automatically happen, but maybe you got connected to the inbuilt data source or something that is structured like that.
Okay.
That's okay. Why is the value? Yeah, the value is not appearing is what. Okay, can you take profit to the column shelf from your text shelf in the marks card? Take it to the column shelf. Drag it on
Okay.
the column shelf. Bars also not coming. No, something is wrong here. Standard. Okay. What I am thinking is
No,
make it
it's
back a
not.
text table. Make it a text table again. Click
Okay.
on text table. Okay. Click on that. Huh. Now you come here into your come towards the subcategories list of subcategories. Yeah.
Okay.
No, I'm thinking maybe it's not something to do with size. Can you click on size shelf in your marks card?
Yeah. Okay.
Increase that. Nothing happened. I don't know if I can take control of your screen.
Yes, you can. Okay. So I think you have got the control.
Okay, I will do. Oh, all right, great. What I was thinking is, so when we take this profit here, you see, the space is there. This is the space allocated to show the profit data, but the values are not appearing. Marks not appearing.
Is it? I mean, I have installed this 2020.1. By default, I've got the sample superstore with the
Yeah.
tab.
Superstore is inbuilt with it. Yeah. I don't know. Yeah.
Okay, shall I
Doesn't
try
work like this.
reinstalling it?
Yeah. Try to repair it. Wherever you have that exe file downloaded, you double click on it. It'll give you an option to repair. So maybe
Okay,
something went wrong with the installation. Okay.
okay.
All right. I'll take back the control.
Yeah. Okay, I think you can share the screen now. Yeah.
Haha.
Fine.
Right. Is there any drag option near sheet 3? No. Yeah, Ganesh, you can install Tableau latest version, which is available for a 14-day free trial. Okay.
Okay.
I will just give you the link. You can download it from there. Yeah. Okay. From that link, you can take it. All right. So
Sure.
we have our text table built and we are showing sales as a separate column in there. Now I want to show discount. So what will I do? Simply drag discount or even before that. Uh, Okay, let's take a break here. Okay, we have our text table with 2 columns in it. Take a break here for 10 minutes. After the break, we will continue our discussion on the same thing. Yeah, Tableau public is more than sufficient for now. Yes, Rani, it'll do. All right, I'll see you people after 10 minutes. Thank you. Hello everyone. I hope you're all here. We will continue with our discussion. So we are looking at how to create a text table from module 3. Okay, we began our discussion on module 3, where we're looking at how to create a text table, which you will mostly find in financial reports. We have seen how to create a table with 2 columns, but here observe, the moment I take the second measure and place it inside the text table, a lot of things have happened here. Okay, it's not just that we are getting sales as a separate column, but a lot of things have happened. What is it? You will all notice something called as measure names, which comes on the columns shelf. You will notice that something called as measure names has come up on the filters shelf. On the text shelf, where earlier we had sum of profit, it is now replaced with measure values. And there is a measure values legend or card, which is telling us that we are looking at profit and sales information, right? So now this brings us to the next concept on what is this field measure names all about and what is this field measure values all about. Okay, so whenever we get connected to any data source in Tableau, the data from that data source, the fields from that data source are segregated as dimensions and measures. We know that. But apart from that, Tableau will create by itself, it will generate a few additional fields, which are called as generated fields. What are the generated fields? Measure names. It's a generated field that you will find in the dimensions pane, which contains the names of each and every measure in the data connection. Then there is measure values, which is also a generated field, which comes in the measures pane that contains the actual values present in these measures. Then there is count prefix with the name of the table from which we are taking the data. Okay, count is the number of records. Latitude generated, longitude generated. Now these generated fields actually have an italic font, right? Italicized. You can see they are slanting. That is how we distinguish between a generated field and a normal field from the data source. So measure names is a field that contains the names of the measures. Measure values is a field that contains the actual values present in those measures. Count is the number of orders, number of records. Latitude and longitude are the coordinates for the places which Tableau recognizes. Okay, these 5 things are called as generated fields, of which we will be looking at measure names, measure values, and count today. Measure names is simply a field that contains the names of the measures, but by itself, standalone, by itself, it has no significance. Meaning, if I use measure names on any of the shells, nothing happens. It will simply give me a message saying no measure value. It will give a message saying no measure value. So measure names will become significant only when it is combined with measure values. I'll take measure values and put it in the text shelf. So you can see some rows. So we can see the names of measures appearing as rows. Measure values is on the text shelf. So the actual data in the measures is appearing as text information. Right? Did you understand what is measure names and what is measure values? It is simply a generated field, something but Tableau will provide to us like a bonus, where it has one field which contains the names of the measures and one field which contains the values in the measures. What is the purpose? Whenever you are creating a chart where you're dealing with multiple measures, wherever applicable, Tableau will automatically make use of measure names and measure values. Okay, like in this case, we are creating a text table where it is automatically making use of 2 measures, right? With 2 measures, so it made use of measure names and measure values. Now suppose I want to show discount. Now let us look at count also. Count is the total number of records in the data connection. That is 9,994 records we have. Okay. Suppose you check the count. If you want to check the count, You can see of the 9,994 records, 775 records belong to accessories subcategory. 466 records belong to appliances subcategory. 796 belong to art. So that is what count will tell you. Number of records per member in the dimension. Now, along with count, I will also show discount. So I'll take discount inside here, and I'll take quantity also inside here. So I have a text table showing me 5 different things here. How to create a text table is clear to us. Now, how do we enhance this table in such a way that it will reduce the cognitive load on the person who's trying to examine this report or look at this graph and try to make sense out of it or understand it, right? How do we reduce the cognitive load? Suppose I ask you a question. Which subcategory is contributing to the highest sales? How will you answer it? You will have to scan through all the data in the sales column. After observing all the values, you will come to the conclusion that phones is having the highest sales. Which subcategory has the least profits? Then again, you have to quickly scan through the entire data and understand that tables has the least profits. So it is not making our life any easy here. Correct. Now, how do we make it? How do we enhance this report to make it more easily readable? How do we make it easily readable? We can add color here. Okay, we can add color for that purpose. So what do we do is, we will convert this simple text table into a highlight table. To the background, to the cell, we will give a color. The color will kind of give us a rough understanding of the values. Okay, now how to do that? It is a two-step process. I request you all to observe very closely. You will use measure values for this. Okay, so we'll take measure values to the color shelf. Drag the measure values field from the measures pane and drop it on the color shelf. Please do this, all of you. Once you do that, you will notice that the color of the text will change. Color of the text information in the text table will change. But do we want the color of the data to change or the color of the cell to change? We want the color of the cell to change, right? So there is another thing we have to do here. Change the mark type. Now every data point in Tableau is called as a mark. Every data point, which is nothing but value here, is called as a mark. The mark type is text. Automatically it is T. T stands for text. Change that to square. Once you change the mark type to square, you will get the desired result. The color of the cell in that table has changed of each cell depending on the data present in the entire table. Depending on the data that is present in the entire table, however. So Tableau, how did it decide what color should be given to the cells depending on the data that they are holding? You will find the color legend which comes up on the right side of your screen. In case the show me panel is open, it will cover up the color legend. So you close the show me panel and then you will be able to see the color legend. Okay, measure values, color legend. Now what is this telling us? It is telling us that the minimum value in the table is minus 17,725. The maximum value in this entire table is 330,007. And based on this minimum and maximum, based on this minimum and maximum, Tableau has accordingly given to the colors to the values. You see this line here is 0. All the values close to 0 are getting shades of gray. That is why these are all in shades of gray. But is this correct? This is not correct, right? To take the entire data in the table and then decide what should be the color for individual columns is not really correct. It would make more sense if Tableau can take the data column wise. Look at the data per column, means per measure, and then decide what should be the color given to the cells depending on the data in that measure column. Correct? So what we will do for this is go to the measure values pill associated with the color icon. Okay, measure values associated with the color icon. Click on the drop down menu and use the option called as use separate legends. Select the option use separate legends. Once you select this option to use separate legends, job done. You will see on the right side of your screen that Tableau has given a separate legend for each and every measure. Okay, profit has its own color legend. Here you can see negative values coming up in shades of orange, positive coming up in shades of blue. Quantity has its own color legend depending on the high and low in that column. Okay, now all of them are however using the same color, though it is a different scale of values that we are dealing with, different range of values, they're all coming up in blue because that is the default color. Okay, let's change them one by one. For count, how do you edit the colors and use a color of your own choice? Here is you just double click on the color legend, the edit colors dialog box will open. Here you can choose a color of your choice. Okay, double click on the color legend, choose from the palette any color of your choice. Or when you double click on the color legend, if you're not happy with the colors that are being offered in the palette, you can click on the color box. When you click on the color box, you will get this select color. So you can basically pick a screen color of your choice. You can pick any color. Let's say I want that kind of shade of blue. Say I want something like this. Okay, so you can choose different colors like that. So that is about text tables and how we convert them into highlight tables. Okay, which part? Sorry, I didn't see your message. So you will have to go to measure values and use the option called as use separate legends. When you select the option use separate legends, then these legends will come up. Coloring, maybe you can unmute yourself and tell me exactly which part, changing the colors or bringing the colors in the first place. Changing the colors, you double click on the color legend. Or every color legend, is your show me panel open? If show me panel is open, they will all be covered. You will not be able to see the color legend. So make sure that the show me panel is closed. Okay, then you either double click on the color legend. This is called as legend continuous. You see the color is also continuous because this is a measure value. Now you can click on this drop down icon and choose edit colors, or you double click on the color legend. Either way it is fine. Okay, now from here, if you're not happy with the colors available in the palette, I was telling you can also click on this color box and pick a color of your choice, which you can use to represent your data like that. So everybody okay with the concepts of text table, highlight table, generated fields? All right, so let's proceed to the next graph that we will look at, which is a bar chart or a bar graph. Bar graph is one of the most common ways to visualize the data, and it is used extensively for comparative analysis. extensively used whenever you are asked questions pertaining to comparative analysis. There are many other graphs which come under the umbrella of comparative analysis because it's a very widely used, or it's a requirement that comes up very widely. Let us say you are working on a project with 10 requirements, at least 5 out of it will be on comparative analysis only. So for every request that we have on comparative analysis, if we end up creating bar graphs, it's very likely that our report, the final dashboard, will be full of bar graphs. That is why there are many options or varieties in which we can represent the data that belongs to comparative analysis category. One of it being bar charts. So at a glance, it will help you understand the highs and lows in the data. Very quickly, you will be able to understand the relative performance of the members in the data. So it will just tell you everything about your data, which member is having the highest measure value, which member is having the least measure value, where do they stand with respect to each other, right? All this information you can get very easily when you create a bar graph. So let's create a similar bar graph which is going to show us the profits across different subcategories. Okay, so how to do it? You can manually take subcategory to the rows shelf and manually take profit to the columns shelf by doing a drag and drop, or you could also choose to select the subcategory and profit fields, go to the show me panel and click on the horizontal bar icon. Anything is fine. Okay, please create it. Try to create a bar graph. Right, how will you do it? So we'll go there, open a new worksheet. You can either select profit and subcategory. For multiple selection, you will have to hold down the control key. Okay, and go to the show me panel and click on horizontal bars. Sorry, horizontal bars. That is one way. Or you can clear the sheet. You can drag and drop subcategory on rows, drag and drop profit on columns. That will also give you a horizontal bar graph. Either way, it is fine. So how do you read this graph? Very simple. It is telling you about the highs and lows in the data, right? It is telling me that I'm getting the highest profits from copiers. It is telling me that I'm getting the least profits from tables. And I also understand bookcases and supplies are giving me loss, whereas these subcategories are giving me profits, right? And you will notice the Tableau automatically orients the bars around 0K on the axis. Means from 0, all the positive values in one direction, from 0, all the negative values in the other direction. This is something Tableau takes care of. Now let me create another graph. This is a graph which is talking about different regions where Superstore is present. And by looking at this graph, I understand West region is very good sales and South region has very less sales. Not very less in comparison to the other regions, it is less, right? Almost 400,000 K. 400K is not a small thing. It is good, but compared to the rest of the regions, it is not doing that well. One point that you have to remember is not just as people creating the graph, even as people who would be reading and interpreting the graphs. When you're reading a bar graph, when you're asked to interpret a bar graph, it would be telling you the correct story about your data. A bar graph would be telling you the correct story about your data only if the bars are starting at 0K or oriented around 0K in case of positive and negative. If the bar is not starting at 0 and is starting at any other value, it may not be telling you the correct story. It may not be giving you the correct information. What does it mean? Let me show you. Now we can edit this axis. This is an axis, right? So when you right click on the axis, there's an option called as edit axis. I will choose edit axis. The edit axis window will come up where I'm going to force the axis By automatically, Tableau will decide what should be the range of values on the axis. I'm forcing the axis to start at, let's say, 380,000. Okay, end I'm not going to change. Only the start I'm forcing it to start at 380,000, not 0. Now there is no OK button here. There is no OK button here. After you have made the modifications necessary, you just have to close it. You see what happened to the length of the bars? And now if I give you this graph, and let us say you have not observed the range of values on the axis, you are just going to take a decision based on the length of those bars. What would you think about South region's performance? Anybody would think that the South region's performance is extremely poor, negligible compared to West and East. It is almost negligible, right? That is the impression we get, which is not true actually. So what are we doing here is we are telling a lie through this graph by editing the axis and forcing the axis for a bar graph to start at a value other than 0. Other than 0, we are telling a lie. Okay. And this concept of telling a lie through graphs actually has a name. It is called as telling lies with ducks. Yeah, I use the fit axis option. 1 second. Now we spoke about Mr. Edward Tufte, who I said is the father of the data visualization principles, and he has laid down a lot of rules. We saw at Tufte's integrity rules when we did module 1. He happened to walk into a store that was in the shape of a duck. Okay. And when he went into that store, he realized that this store had nothing to do with ducks. It was not selling any products pertaining to ducks. That is when he came up with this term called as the duck. Okay. Whenever a graphic is taken over by the decorative elements, where we give more importance to the decorative elements or computer debris rather than the actual quantitative information, such visualizations are referred to as ducks. On top of that, if we go ahead and tell a lie through the chart, then that is called as telling lies with ducks. Like here you can see, this is the actual sales by region, and by editing the axis, we have we are telling a completely different story altogether about the data. So that is called as telling lies with ducks, which we should ideally not be doing. All right. So even if you're interpreting the chart, when you don't edit the axis, even if you're interpreting the chart, make sure that the axis range starts at 0. Only then you're getting the correct picture about your data. Clear? Bar graphs, and what is the point that you have to, I know, very simple charts. Bar graphs are very simple, very easy to read and understand and create also. However, this is one small thing that you have to keep in mind. Okay, how to create a bar graph? Now we are looking at the data for different subcategories, for example. So I'm taking subcategory to the rows shelf. Names of the subcategories will appear as rows, and then I have taken profit to the columns shelf. Okay, so automatically Tableau created a bar graph for me. You see, every data point in Tableau is called as a mark. Okay, every bar here is nothing but a mark. What is the mark type Tableau has chosen to represent the data? Automatically it is using bar. Clear? Now let us change the orientation of these bars. Rather than having horizontal bars, I want vertical columns. How to do that? I don't want horizontal bars, I want vertical columns. So I will just click on this icon on the toolbar, which is used to swap rows and columns. It is used to swap rows and columns. So when you click on the swap icon, what happens is whatever was on the rows shelf, which is subcategory, it moved up to columns, and whatever was on the columns shelf, which is profit, it came down to rows. And we have our bar graph only, but it is vertically oriented. You can also control the color of these bars. Like each subcategory belongs to some category or the other. Okay, I'm bringing category before subcategory. Each subcategory belongs to some category or the other. So I will use category on the color shelf. Each category coming up in a different color. Okay, so I'll remove it here. Whenever you bring any field to the color shelf, it is going to give color to your graph. Here each subcategory belongs to some category or the other uniquely. It does not belong to multiple categories. It belongs to only a single category. So each subcategory is colored by the category that it belongs to. It is colored by the category that it belongs to. Okay. You can also control the size, the width basically. Let us say I want to take sales to the size shelf. So the width of the bar is indicating sales. Wherever you see wide bars, the sales is high. Wherever you see very thin bars, the sales is extremely low. These art, envelopes, fasteners, and labels, the sales is extremely low. And very strange observation. We can make one very interesting observation actually. Tables, the width is quite good, at least compared to all these things. The width is very good, which means it is doing good with respect to sales. However, when it comes to profits, it is going downwards. It is giving us a loss. Okay, so like this, you can control the color of the data points. You can control the size of the data points. Okay, I'll remove sales for now. Let's keep it like this. Now this is a bar graph. You may also want to represent this data as a circle view, which is also used for comparative analysis. So what is a bar? Basically, it is the data point tied back to the header, right? Like this is the profit of copiers around 55,000. It's getting tied back to the header, indicating that it belongs to copiers. So this is bookcases, which is a loss of so and so value, and that is bookcases, we know. This is the value for binders, it's getting tied back. So instead of having it like this, you can also choose to just represent the data point itself. Well, how to do that? Right now mark type is bar. You can change the mark type to circle. That is one way. When you change the mark type to circle, what you get is a dot plot. Okay, it's not, it doesn't have anything connecting it back to the member that it belongs to, but we know this is copiers. Okay, this is tables. The placement is telling us about the profits. Higher the dot, higher the profits. Lower the dot, lower the profits. If it's going further low, below 0k, it is loss. All right, so you can do this, or you may also change the mark type to shape. When you use the mark type as shape, you will get a proper circle. This is a circle view or a circle plot. Circle view or a circle plot. So I'll do one thing. I will use sales instead of profit here. And profit I will use to control the size. That's, I think, more meaningful, right? So you can click on the size shelf and the slider will come increase the size of the circles. So the position of the circle, the placement of the circle is telling you about the sales. The size of the circle is telling you about profits. Color of the circle is telling you which category that particular subcategory belongs to. Getting it? Whatever we convey through a bar graph, we can convey the same information even by creating a circle plot or a circle view. Please do all this, whatever we have discussed so far, and let me know if you have any questions. Whatever we have covered till now, please replicate. You can see which fields are present on which shelves. On the rows shelf, on the column shelf, observe the colors shelf, observe the size fill on the size shelf, fill on the color shelf, and try to replicate this. So we have covered bar graphs and circle views. Next thing we will do is a bubble chart. Okay, if the field labels are not coming vertical, if they're coming horizontal and overlapping, this is a field label. You right click on it and you will find the option called as rotate label. When you select it, the orientation will change. So maybe you're getting it like this. You right click and select the option rotate label. Okay. Did you get vertical labels, Ibrahim? Okay. The course is 15 working days, 15 weekdays, Monday to Friday. Today is day 3. So we have 12 more days to go. We can save this in default or any other place. Means save, you're talking about saving the workbook. You just can save it anywhere you want. You can go to save as and you can create one folder for all the workbooks and you can save it there. Save it as a packaged workbook better. Okay. So like even if you open it on any other machine, it will work fine. All right. Now let us discuss briefly about how do we label these data points. Now we are getting the data point, right? Each circle is representing the profit and sales for a particular subcategory, which belongs to some category, right? Now let us talk about giving a label here. When you hover the mouse pointer towards that circle there, you will see that some information is coming up in a rectangular box. That is called as a tooltip. Okay, this is a tooltip. What will the tooltip show? By default, it will show all the data that is used to build that graph represented by that point. That is tooltip. Then you may also give a label to these data points. How do you give a label is, there are many ways of doing it. You can click on the text icon on the toolbar. You can click on the label shelf and turn on the show mark labels checkbox over there, or whatever information you want to use as a label, whatever you think should appear as a label, just drag that information and drop it on the label shelf. So I want to label it with by profit and also with sales. So I dragged profit there, I dragged sales there. Okay. Now here, when you click on the label shelf, there are a lot of options, which I want you all to explore today. Okay. Explore these options, see what happens with each of these options selected, and do little self analysis. If you have any questions, tell me tomorrow. We'll discuss it tomorrow. Did you understand? So how do you label each and every mark? Sorry. How do you label the marks that are present here on the graph? Every data point is called as a mark. How do you provide a label to that mark? Called as mark label. Marks card label shelf you have to use. Mark label. As I told you in Tableau, it's all about identifying the right place, for creating the things. So we are talking about labeling the mark. Every data point is called as a mark. I'm talking about labeling the mark. So where should I go? Connect it back. I have to go to the label shelf in the marks card. Mark label. Click on that. You will see different options. One thing is you can turn on the mark labels. Okay. It is showing us the sales information by default because sales the is the first measure there, right, on the rows shelf. If you want to label it by profit also, take profit also to the label shelf. It replaces sales. Now you take sales to the label shelf. So with whatever information you want to label the mark, drag and drop that information on the label shelf. That is one thing. Okay, after that, if you want to modify, edit, click on the label shelf and try out all the options present here. Everything I want you to try. Please, all of you, please try everything here. Tomorrow we will discuss. Okay, so for now we will proceed to the next graph. How to highlight categorical data means, okay, so I will discuss after the session. Okay, give me a few minutes. Next chart we will learn about is how to create a bubble chart, also called as packed bubbles. Packed bubble is also a chart that is used for comparative analysis. As I told you, we have a lot of charts that come under the umbrella of comparative analysis: bar graphs, side by side bars, circle views, packed bubbles, all these come under that category. Now, bubble chart is a very unique chart where we represent the data as a cluster of circles. We represent the data as a cluster of bubbles or cluster of circles. Okay, and how many circles or how many bubbles will be there in the bubble chart, that is decided by the number of members in the dimension. It is decided by the number of members present in the dimension. Now, what is going to be the size of the bubble and what should be the color of the bubble? What should be the size and what should be the color of the bubble? That gets decided by the measure that you use to control the color and the size. All right. So let's create a bubble chart, which is also used for comparative analysis. So let's say I want to look at the profits and sales for different subcategories. So I have selected profit, hold down the control key, select subcategory, select profit, select sales. Make sure you have selected all the three. Whatever key you use on your keyboard, generally for multiple selection, use that. After you have selected these three fields, go to the Show Me panel and click on the Packed Bubbles chart, which is the last chart on the Show Me panel, which is the last chart that you see on the Show Me panel. Click on it and the bubble chart will be ready. However, how many members do we have in the subcategory dimension? How do you know how many members we have in the subcategory dimension? Is any chart that you create, the number of marks here, will appear below your data source tab on the status bar. 17 marks means we have 17 subcategories. Okay. Now, here 17 subcategories, but only 14 circles it's able to show. There are 3 subcategories which are giving us loss, which Tableau is not able to show. We saw in the previous chart, no, 3 subcategories giving loss. Tables is giving a loss, bookcases is giving a loss, supplies is giving a loss. So it is all negative. Loss means negative, right? So here Tableau is not able to show those 3 subcategories which are giving us loss. Why so? Why is it not able to show the subcategories giving us loss? Because profit field, which has the information about profit and loss, is actually on the size shelf. How do I know it is on the size shelf? It has the size icon associated with it. This is the icon for size. So we are controlling the size of the circle through profit, and we cannot have a circle with negative area. Correct? We cannot draw a circle for negative area. Therefore, those 3 negative are not able to come up here. How do you fix this then? Any thoughts on how do we fix this problem? What do you suggest? So we'll remove profit. Okay, we'll remove profit. Let us keep only sales. We're getting all same sized circles. All of them are here. Tables also is there. Supplies also is there. Okay, bookcases also is there. Everything is there. All right. Now, instead of this, what you can do is you take sales to the size shelf. Interchange sales and profit. So what you will do is take the measure which is having only positive values, like sales, which is having only positive values, use that on the size shelf. They will not lose any data. Okay, everything is positive here. Sales can never be negative. It's either 0 or positive, never negative. Then use the measure which is having both positive and negative values, which is profit, on the color shelf. So now we are controlling the color. Color is representing profit. Wherever I see shades of orange, I know it is a loss. But the circle for tables is very big, means sales wise it is doing extremely good. Profit wise it is giving us the worst loss. Copiers on the other hand, smaller circle for sales, but it is having a deep shade of blue. What does that mean? Even though the sales is less, it is giving us the highest profits. Getting it? That is how you read a bubble chart and you interpret a bubble chart, and take care when you're creating a bubble chart to ensure that you have the measure with both positive and negative values represented through color, measure with only positive values represented through size. Everybody okay with this bubble chart? Please replicate it and let me know if you have any questions. This is where we stop. I will not start anything new today. Whatever we have discussed till now, in that if you have any questions, I'll take it up. Now here I will just tell you one more point. Okay, don't leave yet. You have to share your attendance also. Don't leave yet. This bubble chart, after you have created it, suppose you change the mark type to text. Right now, what is the mark type? Circle. Suppose you change the mark type to text, it will become a word cloud. It will become a word cloud. Word cloud is something where we can show the names of the subcategories. Okay. And the color and size can be controlled using the measures. Names of the members in that dimension will appear, and the color and size are indicating the measure value. So very big font size for phones, which means very high sales happening there. Very small font size for labels and art and fasteners and envelopes, less sales. Deeper shade of blue, higher profits. Deeper shades of orange, bad profit. It is actually a loss. Getting it? All right. So here I will stop the discussion and also stop the recording.